Okay, for lecture 35, we're going to use those oxidation numbers to work with oxidation reduction reactions, which we also call redox reactions. So you should know these definitions. We're going to use each of them. Determine which of the following are redox reactions, which are non-redox reactions. For each redox reaction, label what species is oxidized, what's reduced, the oxidizing agent, the reducing agent, and write all of the oxidation numbers. Woo, a bunch of stuff. Well, to find what's oxidized, what's reduced, what are the two agents, we need to write the oxidation numbers, so we have no choice with that, so that's not a big deal. Now, what you do first, before you start anything else, you might as well work out the oxidation numbers. These are both elements, so this is 0, 0. Oxygen is -2. So phosphorus is going to be +5. And if you look, we have 4 times 5, that's 20. And then we have 10 times -2 is -20. Adding those up will give us the species charge, which is 0. So that's correct. If you have to do that out by an equation, that's fine. Now, the phosphorus went from 0 to +5. We can stop there as far as redox versus non-redox. If the charges, the oxidation numbers don't all have to be 0, but if they're the same on both sides, if this was 0 and this is 0, this was 0 and this is 0, there was no redox reaction. There was a reaction, but it wasn't a redox reaction. So we can say that this is definitely a redox reaction. Now we want to know what happened. What was oxidized, what was reduced? Well, phosphorus went from 0 to +5. It gained a positive charge, means it lost electrons. Each phosphorus, we'll just go by phosphorus, it lost 5 electrons. If it lost electrons, that means it was oxidized. That's the definition of it. Usually I put the bracket on top here, but I'm going to be stuck here. Really well done here. So we'll just bring it down. Oxygen goes from 0 to -2. So if it went from 0 to -2, then it gained electrons. Each of them gained 2 electrons, and so it was reduced. Again, by definition. Now, the oxidizing agent. So, so the phosphorus was oxidized. The oxygen was reduced. And the oxidizing agent is the thing that oxidized. Since phosphorus was oxidized, then oxygen must have been the oxidizing agent. This is the most confusing thing for students, is just, I'm going to say it out, but after I say it a few times in class, usually I think students just eyes glaze over because it sounds like I'm just babbling a bunch of nonsense, but I'm going to write this out. I'm going to explain it here in a second. But oxygen was reduced. It must have been reduced by the reducing agent. The only other thing in the reaction, only other reactant was the phosphorus, so it was the reducing agent. Let me just put a box around each of these here. So the phosphorus lost electrons, so it was oxidized, making it the reducing agent. Oxygen gained electrons, it was reduced, making it the oxidizing agent. Now, how I normally explain it is that when you want to travel, you go to a travel agent, or used to, probably still do to some extent, but you go to a travel agent. Travel agent doesn't travel with you. He sends you, he makes you travel. You don't go and say, I want to go to Aruba, and your travel agent says, yeah, let me go, let's go, let's head out. He said, no, I'll send you to Aruba. So the reducing agent isn't reduced. It's the agent that goes on and reduces the other thing. So we have oxidized and reduced, reducing agent, and oxidizing agent. So we've got to remember, think about what they're doing. The other thing here is that the products are not labeled. The products are not oxidized or reduced. They're not reducing agents or oxidizing agents. You should never, in this type of problem, ever do anything over on this side other than add the oxidation numbers so you can see what happened to the reactants. The reactants are the ones that were oxidized or reduced. They're the oxidizing agents and reducing agents. If you put anything underneath here for the products, it's going to be wrong. So just remember, everything happens, the oxidizing agent, reducing agent, are the reactants, and they're the ones that are oxidized and reduced. Okay, so we have this guy here. We have lead is +2, sulfur is -2. We know the sulfur because that's the group 6A rule, -1, +1. Lead is +2, sulfur is +6, oxygen -2, +1, -2. Okay, so we look and we see that the lead goes from +2 to, stayed +2. Sulfur went from -2 to +6. So it lost 2 electrons to go to 0, and then it went to lost 6 more to go to +6. Going across from negative to positive throws people off sometimes, but here it's lost. The sulfur has lost 8 electrons. So the lead sulfide is considered to be oxidized. So normally when you say what was oxidized, you say the whole species, even though the lead wasn't touched. So you say what was oxidized, you say lead 2 sulfide, lead 2 sulfide, which means that the hydrogen peroxide must have been reduced. We'll write it down here, and then we see this. Nothing happened to the hydrogen, but the oxygen went from -1 to -2. So it gained 1 electron. Each oxygen gained 1 electron. And there's 2 of them in each molecule, and there's 4 molecules. That's a total of 8, and that's how when we lost 8 electrons from the lead to sulfide, the hydrogen peroxide gained 8 overall for all of the molecules. So this was reduced. So since this was oxidized, this is the reducing agent. And again, you'd say the lead 2 sulfide is the reducing agent. The hydrogen peroxide was reduced. It was really just the oxygen, but we say the hydrogen peroxide was reduced, and so the hydrogen peroxide was the oxidizing agent. And the reason we say that, we don't specify the oxygen in it, because sometimes the molecules, these are simple, there's just 2 elements in each, but you get some molecules that have 20, 40, 400, 4,000 atoms, and one of them is oxidized, one's reduced. You don't want to specify in that monstrosity which element was reduced. Okay, this one I can finally write the way that you'd normally write it. I didn't have enough room above or below. And of course we don't need to use the brackets, but that's what we normally do here. Let me show you why. And because there was a reduction and oxidation and they have to occur at the same time, this was definitely redox. That was the first equation, or that was the first question. Okay, for this one, write out the oxidation numbers. This is the only way you're going to be able to tell which one was oxidized, which one was reduced. Now take a look here. Hydrogen goes from +1 to +1, chlorine -1 to -1, sodium +1 to +1, oxygen -2 to -2, hydrogen +1 +1. So there was no change in oxidation number for any element. So there was no oxidation, and if there was no oxidation, then there was no reduction. And since there was no oxidation or reduction, this is a non-redox reaction. And a lot of times they don't use the hyphen. So since it's non-redox, we can't do anything further with it. We can't determine what was oxidized or reduced, what was the reducing agent or oxidizing agent, because there isn't any. The reaction did occur. It's a very powerful reaction, very exothermic, but there was no change in oxidation number, and therefore no redox reaction. And the reason that it's important to distinguish between them is that when you have a redox reaction, you have a changing or a transfer of electrons. That transfer of electrons can be used to do work. When there's no transfer of electrons, you can't use the electrons to do work. You can certainly use the heat that's given off here to do work, but this kind of thing here is what we would use to create batteries. We can't make a battery out of this reaction. And I'm going to, even though I didn't leave myself room for this one, I'm going to do it the way that it should be done with the brackets above and below, just to show you what I'm talking about. Because I mentioned it a couple of times now. I'm going to do this fairly quickly. -2 + 2, 0, -2, and then +4. Yeah. All right. So iron goes from +3 to 0. So since that happened, since there's a change in oxidation number, it's redox. At that point, you might not recognize that iron was reduced. Doesn't matter. You know that it's changed its oxidation number, therefore it was a redox reaction, so that answers the first question. Now we go on and we see iron went from +3 to 0, so it gained 3 electrons. Oxygen, nothing happened to that, but the carbon went from +2 to +4, so it lost 2 electrons. And that's how you normally do it with the brackets, just so it gained and lost. And then from there, since we know the iron gained 3 electrons, this was reduced. So it was the iron 3 oxide that was reduced. The carbon monoxide was oxidized. And so this is the oxidizing agent. And this is the reducing agent. Make sure I'm getting pretty good at keeping this on page. So, and that's everything. All right.